in recording.
Okay.
Very official.
Right. Shall we? Yeah. One of the I've called this heat pump procurement, and one of the alternative titles was Zen and the Art of Heat Pump Procurement, because there is a bit of an art to this. There's sort of things that you've got to juggle and get right, and it's not straightforward, simple understanding the technology. It is sort of understanding human issues as well as other issues. Anyway, that's brief introduction. The actual content, what we're going to do is consider, we've already looked at successful case studies in sessions 1 and 2. Session 3, we're going to look at technical aspects of heat pumps. Some of this will be a revision of what we've already covered. And we'll look at the different types of heat pumps, but we are going to concentrate air source heat pumps. Then we'll look at the idea of heat pump performance, and you've got this idea of COP, coefficient of performance, where the idea is if the heat pump takes 1 kilowatt of electricity and it's putting out 3 kilowatts of heat, well, then its COP is 3, because it's you're getting 3 times the heat out for the electricity you're putting in. Then issues like flow temperature will come up, what difference that makes. This is the temperature of the radiators. And then an important issue for heat pumps, which you don't get with other heat pumps so much anyway, is cycling, when the system turns on and off. And that's, well, as we'll see, that's very important because it can introduce huge inefficiencies. And then we'll look at the idea of effective systems and their installation. How what is an effective system? How do you get it installed? And some of the hurdles and what sort of Zen you need to get a good installation. Okay. So next slide. Right. Okay, so the topics. We're going to start off with the heat pump challenge, i.e. what you need to overcome to get your heat pump, your effective heat pump. And then we're going to look at the idea of heat pumps as a retrofit solution. And then the rest of the slides, in fact, most of the slides are to do with the procurement process. We'll go through those in sections. Okay, so the heat pump challenge. Can you apply the technology? So you have this technology you've heard about, and it sounds, as if it's something really good for, it's electrical, so you can, if you've got low carbon electricity, which we're more and more going to, well, then obviously it's a very green source. But then it's not direct electric. We've got this idea of the COP, so you should get out possibly 3 times the amount of electricity you put in, 3 times the amount of heat for the electricity you put in. And then there's the, can you find an installer who's able to install an effective system?
Well, we've lost you, Andy. You still there? Hopefully it's not the storm hitting. Andy, can you check your bandwidth or your sound? Not sure. Lost your sound. We lost Andy completely. I don't want to. Can you see him, Florence? Sorry, because I can't see the participant list right now.
The participant, he's gone completely, actually.
He's dropped out. His internet connection's dropped out. Okay. Sorry, everyone. We'll just wait for him to rejoin. I could pause the recording, but hopefully he'll be back with us. He did warn there are storms in his area and it affects his internet connection.
Well, while we're waiting, we've got a question from Eleanor.
Great.
I've been told I can't have an ASHP in the house I'm about to buy. Other suppliers have already quoted me for supplying one. All are working from standard estate agent info. Is it possible that some houses don't suit ASHPs? I'm not entirely clear who's telling you that you can't have the ASHP. But is it because you've got no outdoor space? It might be that your EPC is showing too much heating demand. Sometimes an installer will look at your heating demand and do the calculation, and it turns out that you'll spend more on your electricity, so they'll say it's not suitable, but that's really up to you whether you want to spend the money on the electricity or not. So yeah, bit of a tricky one without additional information, Eleanor. Oh, yeah. Radiators would have to be too big for the walls. It sounds like you've got too much heating demand for the radiators that you need to put the heat into. So with heat pumps, you're operating at much lower temperatures, so typically your radiators need to be larger than traditional boiler radiators. But if you do retrofit as part of, if you do insulation works as part of your retrofit, you might be able to get that demand down sufficiently to get the right number of the right radiators, or you could go for underfloor heating. Does that answer your question, Eleanor? You can have radiators that are fan assisted, for example, but without any more detail, and I can't really give you much more. So if you wanted to send in the particulars, then by all means do. I'll have a look. Yeah, so Ken is reiterating it, that you at some point it's just not viable to try and meet that heating demand that you've got because your insulation isn't good enough.
Started off with the idea of the heat pump challenge and how can you apply the technology. This was a key issue because you've got the technology, you want it to work for you, so you need to understand it. Then there was the issue about, although you understand the technology, which you have to a certain extent for a heat pump, will your installer, put in a system, an effective system that works in the way you want it to work. As we know, some installers are more competent than others. The other issue with the installer is, are they well motivated? Some installers have, well, different motivations. Some aren't particularly into having an efficient system, so they suggest, you know, high temperature stuff and whatever, which you want to keep your flow temperature, your radiator temperature, as low as possible. And sometimes they're more motivated by the money than anything else, and that's something you need to avoid. There are good installers out there, but finding them is perhaps a little bit more difficult with a new technology like heat pumps than it might be, say, for a gas installer. Okay, so that's the challenge. So I'm going to move on and look at the idea of, well, the topics. So, sorry, I've covered that slide before. We're moving on to the retrofit solution. Okay, the first thing about the retrofit solution is you want this thing to be, the heat pump, to be reasonably efficient. What sort of efficiency should you go for? Heat pumps, particularly in the UK, they're still in their early stages. So if we look back to the Energy Saving Trust reports, in 2008, they reported heat pumps to have a performance coefficient of efficiency of only 1.8, i.e. you put 1 kilowatts of electricity in and you get 1.8 kilowatts of heat out. By 2013, they'd said, the average COP was now 2.8, which is a whole lot better. But when you look at it, what they did was they got rid of all the installations of systems they didn't, for whatever reason they didn't think were good, and they ended up with Mitsubishi, Grundfos and Daikin systems. I know Mitsubishi and Daikin have got good reputations. I don't know about Grundfos, but clearly EST selected them for some reason. And then they help people improve their systems. So even after that help, they only got up to about 2.8. Okay, so don't expect too much out of your system. As I'll say later, aim for 3. If you get more than 3, that's a bonus. Okay, so if we go on to, right, before I go on, is everybody okay? Can they hear me okay? Because I don't know with this phone.
Yeah.
Good, okay, right, I'll carry on. Right, so the retrofit solution 2, you need to integrate your heat pump with your other the other techniques you're using for retrofit. Obviously, the insulation is the one we all know about. The key issue is if your house is well insulated, it doesn't actually need so much heat anyway, and you're keeping the heat in, as it were. In fact, a good way of looking at the insulation is it's a bit like a leaky boat. If you're trying to pump heat into your house and it's not properly insulated, well, then it will come out again fairly quickly, because this is what happens. In the same way as with a boat, if it's leaky, you're going to have to pump a lot of water out of it. It's going the other way, but it's a sort of analogy. So anyway, insulation's important, but solar gain actually is quite an interesting thing to think about. Can you get, for instance, for my house, I've got a conservatory across the southern side of it, which does give me quite a lot of useful heat in the spring and the autumn. This time of the year, of course, you're getting too much heat out of it. So if you put a conservatory on, make sure you've got lots of venting and automatic windows opening and whatever. Air movement's another issue that can take your heat out a lot. And then if you've got a thermal store, that actually, if you like, moderates the temperature. You've got, in the case of my house, it's a stone-built house, and I have thick internal walls which count as a thermal store, of, 30 tons or whatever. So it's good from that point of view. Right, so you need to reduce the heat loss to the output of the HP, either at the time of the installation or later. So you could put your heat pump in knowing that you're going to do the installation and whatever over the next year or two, which is what I did effectively. I just said, right, I'm going to have a 5 kilowatt heat pump and make sure that my house works effectively with a 5 kilowatt heat pump. And in actual fact, even though when I installed it, I hadn't done all the insulation, I didn't have any problems in the winter. So I've taken the case of a semi with a floor area of 150 square meters. So the target could be a 6 kilowatt heat loss after it's installed, and then you'd have a 5 kilowatt heat pump for that. Okay. So these are the issues then about retrofit. You want to try and think about how you can reduce the heat loss anyway from the house, and then apply the retrofit, put the heat pump in, and then your system should work. Right, procurement process. I've identified 5 different issues or 5 different processes or stages probably in the procurement process. The first thing you need to do is to decide on the heat pump to be installed. I would do this. I mean, some people might say, well, the first thing is to choose an installer, but I do think for heat pumps, you really need to have your own ideas as to what you want, and not be influenced too much by the installer. Certainly not right at the beginning of the process, because it's important that you understand what you want for your retrofitted house, and you make the right decision is made for the type of heat pump, output, whatever. Choose an installer. We'll go through that process. I've got some things to say about it. Florence will talk about that as well. Design the system. Designing system, this is things like radiator sizing and issues such as that, whether you go for underfloor heating and whatever. The installation process, it's useful to monitor what's happening during the installation, and then finally the daily operation of your heat pump. This is very important, because if you don't, it's not a gas system, it is a heat pump, and it has different characteristics, so I'll go through those when we get to it. You do need to get all 5 of these right. Any one that is problematic will cause knock-on effects to the final, to how your system works. You can, of course, go back. Like, for instance, I chose the wrong installer to start off with. For my second heat pump, I was fairly confident after the first one worked well, but the second one, I had issues with the installer and had to get rid of that installer and get another one. But hopefully that doesn't happen. But it's made me more cautious about installation, and I will talk about that later. Right, okay, so start of the process, decide on the heat pump to be installed. So let's move on then to different types of heat pumps. We've got the ground source heat pump, suitable for new buildings because excavation is involved, and if you've got the excavator there, and I ought to say as well, the people doing the site layout, because one of the problems with ground source heat pumps is getting the underground collectors of heat on the right level. If that's not done properly, you get problems. Right, water source heat pumps. You don't come across these very often. My first heat pump was a water source heat pump, and it was great. It worked off my water supply. Unfortunately, when the water supply decreased a bit, I had to get an air source heat pump. So they can be a useful, they have a role to play. And I know on the River Thames there's been a recent installation where they're using water source heat pumps for London apartments. And then there's a Swedish airport which has heat provided from the sea, taking heat out of the sea and then going into the building and that has been very effective. It's a bit of a showpiece thing. But in the UK, and particularly for retrofit, air source is what is normally chosen, right? And you've got two types of air source: air to water, which is, you know, water in the radiators, so conventional central heating. You can also have air to air, where you just blow warm air straight into the house. And I'll talk about both of these types of systems. But now I'm going to go on to ground source heat pumps. Ground source heat pumps, yeah, extensive excavation or boreholes. The only problem with a borehole is it's typically £5,000 a borehole, and you might need more than one. So that puts the price up. And as I said before, there can be problems with the heat collection system. If the normally what you do is you dig down about a metre or so, and then you put a load of water piping in, and you run a short circuit. You run the water around, and it collects heat from the ground, and then you're pumping that into the house. But if you get an airlock, you've got problems. Right, high cost, £10,000 plus. It is an option for a new build domestic because you've got all the machinery and stuff on site. And if you're going for larger buildings, particularly new build, it makes a sensible option. The best example I know of good ground source heat pumps is Renewable. It's a fairly new, small company. I know about it because I actually invested some money in it. And they run the systems for the care homes. They install them, run the systems, and so they have control over what's going on. And they're a very sussed out company, so they know what they're doing. So ground source heat pumps can be an option, but not normally for retrofit. So air source heat pumps. High reliability potential, right, as factory built. Obviously, it depends on what's happening in the factory. There are good quality heat pumps and not so good quality. You should try and get a good quality one, but I'll go into that on a later slide. The main unit is external, so that does mean you've not got so much inside, which does help in terms of. I mean, you could say that what's inside is probably, well, can be less than you would have with gas central heating, but it depends on the system. They've got potential to perform well in mild Manchester. I looked up the average January temperature, average low January temperature in Manchester, and it's 1.7 degrees, and that means that you're not going below zero. They do actually perform less well below 3 degrees, but they're still okay. I mean, I get, for instance, out of mine, I can still get 2.7 COP when it's below zero, which, you know, that's okay. I mean, normally it's at about 4 COP or 4. Right, if you've got a sun trap, that helps. I've got mine on a west-facing aspect, and it's facing across the valley, and it is a bit of a sun trap there, so that gives me an extra, I get extra heat out of that. London Underground is very interesting because they've got lots of warm air in there that they want to get rid of, and they've just started a scheme where they've got a huge fan, it's 2 meters across, and it's pumping air out of a large chunk of the London Underground, so it's making it more pleasant for people there. And it's going into a large air source heat pump, which provides heating for a lot of dwellings and a commercial centre. So that's an interesting project. But we're looking more, though, at things like replacement for a gas boiler or oil central heating or whatever. If you've got oil or you've got direct electric or something, air source heat pumps can save you money. If you've got gas, it's getting actually so that if you get a good installation in, it'll be a good replacement, and you might save a bit money, you might not. Okay, so air source heat pumps run at cost at about $2,500. That's the basic unit, right? And then up to £10,000. Typically, we're talking about £6,000 if you're including the radiators and all the plumbing involved and so on. Right. Go on now to air to air. Okay. In this case, you're taking the heat out of the air, but instead of putting it into radiators, you're just blowing warm air into the house. Right, you're warming the air up and just blowing it into the house. So it's great if you've got an open plan living space. These units can be very cheap. From about 500 quid, you can get a basic unit. But you're probably better to pay a bit more. But for under £1,000, you can get, a fairly decent unit like the LG system that's come out, and there are others. I was actually corresponding with somebody who put a Hitachi system in, and they were very happy with it. They had an open plan living space downstairs. The other thing is that you can put it into forced air central heating, which is a very common system in Canada and the United States. But that's not common in the UK, but it's worth thinking about. But as I say, that's sort of pioneering stuff. I'm not aware of any systems like that in the UK at the moment. Right. With air source heat pumps, supplementary heating is a good way to go, right? The BRE research shows that with an air source heat pump with an output of less than heat loss at 0 degrees, supplemented by direct electric, can still be more efficient than an air source heat pump with a higher output. So that goes back to what I was saying before. If the heat loss is 6 kilowatts, choose a 5 kilowatt heat pump, not 6 kilowatts plus, and it will still be more efficient even if you have to use a fan heater on cold days. Part of the reason for this is the number of days that you'll have to use that fan heater are very limited, and then very often too people don't tend to overestimate the amount of heat loss you've got, so you don't have to use the fan heater anyway. And you can have other sorts of supplementary heating, such as a wood stove or a gas fire. If you've got gas already, you don't have to have it all taken out. You can put a gas fire in. And I also take into account that with air-to-air, you might put that in as, if you like, a hybrid system. So you've got the gas fire or the gas heating with the air-to-air system. So these hybrid systems are possible, and you have to find the one that works for your particular situation. Okay, so the next slide is about which air source heat pump. There's a huge range, and unfortunately the reliability of these systems is actually wider than with cars. Nowadays, if you buy a car, you can expect it to keep on the road most of the time, but there still are some unreliable heat heat pumps around, so choose carefully. The Japanese invested £1 billion in heat pump research, and they gave all the results of that to their manufacturers. So it's no coincidence that when we talk, like I've got a Mitsubishi heat pump, I know Daikin heat pumps have got a good reputation. The guy I was talking to about his air-to-air system, that was a Hitachi, another Japanese make. So you're relatively safe if you go for a Japanese manufacturer. I'm not saying completely safe. You need to look at what they do or how they perform. Other people do make good air source heat pumps, but again, you have to be a bit careful. I do know, for instance, that NEBE make good heat pumps, but then they have problems with control. If a NEBE heat pump senses that it's below 16 degrees, it will turn on a direct electric system, which can be expensive, you know. And for myself, if I'm leaving the house for several days, I'm quite happy if it's down at 12 or 14 degrees, but you couldn't do this with an NEBE, which, anyway, there are issues with that. I did actually talk to NEBE about it. They might have done something about it in the last 3 or 4 years. 10 years without maintenance is possible. My heat pump has come up to 10 years, and there's been no maintenance to the actual box that sits outside the house. I have done stuff with the replaced radiators and stuff, but it's all it needs is the air intake washed off, because you don't want to clog up the air intake. And small is beautiful with heat pumps. As you know, I'm a big fan of the 5 kilowatt heat pump, which gives you this idea of a house which has only 1 kilowatt of electricity to power it. Okay, yeah, your heat pump will take a little bit more than 1 kilowatt when it starts up, but then it will settle down to about 1 kilowatt. Right, so expected air source heat pump performance. This is the next slide. In the first case study, I mentioned a seasonal COP of 3.6. It was only 2.7 when first installed, and for a lot of people, they might have just left it like that. Because I was a bit geeky, I did push it a bit, you know, and have some alterations to get it up to 3.6. It's now performing better than 3.6, but that's the last seasonal performance I've got. And in case study 2, we saw a heat pump with a seasonal COP of 4, but there were 2 factors in this design. One, it was a very competent engineer. Tristan Lee really knows his stuff, and he was working with John Cantor, and John Cantor has been into heat pumps for 40 years. He built my first heat pump from basic components. The guy just knows everything about a heat pump. So these performances of 3.6 and 4, great if you can do it, but it's a difficult task to get it up to there. It took me several years when I retired getting mine up to 3.6 and past 3.6. Remember the EST average of 2.8, but that was, you know, when they selected certain heat pumps and got rid of the ones they didn't like, whatever. And so 2.5 is okay. Better than 3 is good. That's what I would say. And I would do your sums. A lot of people do this, actually. They take 3 as the value they're going for. And if you do your sums based on 3, you might not get up to 3, but it gives you a fairly good idea of what your costs are. Okay, the next slide is sizing your air source heat pump. You need to start off with an energy survey of your house. This is a fairly sort of professional undertaking, but I think, well, I know that the Carbon Co-op do energy surveys, so you can get them to do an energy survey. I got mine from a guy called Nicholas Parsons, who is very good in this area. So this tells you about what the performance of your house, and a good survey will say, well, if you put in such and such insulation, it will reduce your heat loss to whatever, okay? And you can actually ask the energy surveyor and say, well, look, if I'm putting a 5 kilowatt heat pump in, what sort of insulation and other measures should I take? You know, things like cutting down loss from air movement and so on. And once you've got that figure and you've got a program for that, then obviously that gives you an idea of the size of your heat pump. And note that the heat loss is usually lower than calculated, partly because the people doing these calculations don't want you to come back and say, oh, yeah, you know, you've said the heat loss is X and it's X plus whatever, because that they lose credibility for that. Right, so back again to the idea of a 5 kilowatt output heat pump is good if you've got a 6 kilowatt heat loss. The other thing I would say is a matched pair of heat pumps. If you have a large house and you can't, you know, it's going to be difficult to get it right down to say to a 6 kilowatt heat pump heat loss, and you're looking about, say, 10 kilowatts. Well, then a matched pair of heat pumps works very well, because most of the time only one of them is working. But when that extra heat is needed in January or whatever, well, then the two work together. And that can be efficient, because when one is working and it's producing 4 or 5 kilowatts of heat during, you know, months like, well, December or March or whatever, then it's working very efficiently. Right, I think at this point I'm handing over to Florence. Hello? Anybody there?
Yes, I'm here.
We're
sorry.
here, don't worry.
Right, okay. Sorry about that.
I'm going to stop my...
Okay, so Florence, are you going to...
Florence
put
can
your
screen
over?
share now. Yeah, I've stopped the screen
Great.
share, so you can go for it, Florence.
Okay. Right. So. Can you see that now? Is that visible to everyone?
Yes, perfect.
Right. So I think Andy's already said this in some way. In terms of going out to find installers, then you're ideally you would choose the model first. And there will be different priorities, and it will depend on your heat loss calcs and your peak heat loads, and that will be dependent on your wall build-ups, your roof, your insulation. But there are other considerations. So, you know, someone asked about what other equipment they would need, etc., what space take up that would be. Well, if you go for a monoblock unit, then you've only got the outdoor unit as your heat pump itself, and then you'll have internal, maybe a hot water cylinder. Some are split units, so half of the heat pump is internal, so you'll need space inside and out. and other things. You might be interested solely in energy efficiency, and that will drive what kind of model you will go for. You might even be interested in the global warming potential of a particular refrigerant of that model. You may have to satisfy a planning condition, in which case you'll have to go for a quieter model, and then there'll be controls. So you might prefer the controls of one model, one supplier, or another. There is also a database on the BRE website, which will allow you to select various models with different filters, and it will plot it on this graph. So basically along here you've got your dwelling design heat loss in kilowatts, and then up here you've got your annual efficiency, which is similar to the seasonal performance factor. So that kind of gives you an idea of what how to compare different models for particular outputs and particular ways of matching up the model to your particular house. So as you can see on the left hand side, if you've got smaller or better insulated, oh, what's that? I'm getting messages from Polly, sorry. Oh.
It's all fixed. I had to mute Andy because we could hear an echo. Sorry, Andy.
Yes, so you might have a smaller house or a larger house with better insulation, so you'll be towards the 5 kilowatt mark. If your house is larger, obviously you will be at the higher end of the heat pump sizes. And I appreciate that both Tristan and Andy have managed to make 5 kilowatt heat pumps work for them. And that's great, and you will get the best efficiencies if you manage to do that. But there will be people on this course who still want to switch to a heat pump without necessarily having the lower heat demands, and that might be simply because of the age of your house or the size of your house. So I don't know how we're doing for time, Polly, but I could go to the BRE website and just mention the...
It's 10 to 7, but yeah, I think it might be worth sharing that with people. Yeah.
Just to show you where you put the inputs in, here you can select your the manufacturer. For different flow temperatures you will get different efficiencies, as Andy has said. You can select whether compensation's on or off, and we can get into that in more detail. And then you can just add these models to the graph, and it will plot them on here, so you can have a look at a Daikin compared to a Mitsubishi, for example.
This is great.
Let's choose a different size. So there you go. So Daikin's just performing a little bit less, according to the product characteristics database that the BRE have compiled. Right, so if I go back to the PowerPoint, right. So how do you go about finding an installer? This is going to be, this is probably the trickiest part, although we do have Ken who's offered to help us out a little bit on the installer front. And ideally we'd have a Ken in every region of the UK. But it's trying to figure out who that Ken is. So there will be plumbers and installers that say they can install a heat pump. do they actually have that experience in that, or are they willing to learn? And then you could contact the manufacturers and say, who installs in my area. There is, if you are going for the renewable heat incentive, and I'll just briefly mention that, then that installer would need to be MCS accredited, and there's a very good website where you can find local installers that are accredited. But if possible, do use a recommendation of a recent installation. I think that's your best best bet, really. Oh, I thought I had the map here. Oh, here we go. Sorry, I'll just go back. So this, for example, is taken from the MCS website. You just put in your location, and it'll give you the nearest installers. Briefly on the renewable heat incentive, you can get information on this from the government website and the Ofgem website. There are certain eligibility criteria and uses, so it has to be space heating or domestic hot water, and it has to have certain performance factors. You need to carry out some insulation work. That could be cavity or loft insulation, and the way the grant is calculated is based on what's shown on your recent EPC, which is why, and there's a question in the Q&A about this, and we'll come back to that. Unless your EPC has been updated to your most recent insulation, then it's not going to reflect what you actually consume, apart from the fact that the assumptions in the EPC are very different to actual real life. So that's why you'll find quite a discrepancy, and it's quite hard. And I'm hoping Ken will shed some light on this. It's quite hard to get the installer to accept that you want a smaller unit. The grant is paid over 7 years, and it's calculated on a rate per kilowatt hour of your yearly consumption, but that's just the renewable portion. So if you think of your COP of 4, and you've got 1 part electricity and 4 parts heat total, then the grant is paid on the 3 part, and there's a cap. But you have to make sure that the installer is MCS accredited, and you have all the paperwork in place. I won't go through this in detail, but this is taken from the MCS website. It's the calculator for going back through, for calculating exactly how much you get. You do get an additional grant for putting metering and monitoring, yeah, that's all I was going to say tonight about the RHI. And you might have heard recently about the Green Homes Grant Scheme. So this is the government's £2 billion pot of money where householders can apply for vouchers covering some of their insulation works, but also air source and ground source heat pumps and solar thermal, if you've suitably insulated your home. So and they have confirmed this week that you can get both the RHI and this grant. The complication is, on top of MCS accreditation, you would need to make sure your installer is Trustmark registered. So yeah, I'm not quite sure how that's going to work. So later this month, you'll be able to access the advice and support. This is taken from the Trustmark website. I think that they're putting a simple energy advice service in place. And the vouchers will be issued from the end of September, so you can commence works then. And I think that's the end of my bit. Andy, if you wanted to have a break there, or we could do some questions.
Andy, you still with us? Oh, actually, you might be muted. Sorry, Andy. I don't know if you can unmute yourself. Maybe not. There you go. Sorry about that, Andy.
Okay, yeah. Right. Okay, then. Now, yeah, I'll whiz through my slides, and it might be, a bit more than 10 minutes. Is that okay? Am I on?
Yes, you're on.
Right. Brilliant. Okay. One thing I will say, because I remember I discussed this with Florence, is I think the government's latest green money or whatever is only up until March. Is that right?
It is.
I think the money has to be spent by March.
It is short.
Right. That's a very short.
Yes, it is.
Time. So what I suggest is, if you're after that money, cooperate with people. Try and get a group of you together, so that there's some expertise there that you can push ahead with it. And I understand also Florence was saying that you can apply towards the end of this month. Is that right?
I think that's when you can inquire about it. Yes.
Inquire. Yeah. Okay. And then you'll get something. Right. Now there's a question about whether you can get both this grant and RHI, and let's see what happens, because it's changing a bit as we're going along. So the thing to do if you're after that money is to work with people who are, if you like, share the load in terms of getting information on it. Anyway, I'm going to crack on now. So we've done sizing your air source heat pump. So we're on to the next slide, which is right, choosing an installer. So yeah, next slide again, please. Right, okay. Now this has been Florence has covered this a bit, but be careful, right? MCS installers are not necessarily people who will do a good job for you, and most installers will say they're an approved installer for X or Y system, but it doesn't mean they're good at that. Really, the way to do it, I think Florence mentioned this as well, is when you've decided what air source heat pump you want to install, phone up that distributor. For instance, in Manchester, there's a distributor for Mitsubishi heat pumps. Phone them up and ask them who are the people that they send out to troubleshoot problem systems, i.e. who are the people they've got complete faith in. And that I did that after I had problems with one installer who was an improved installer, but actually he made a real mess of things. So it's quite convenient in a way that I was able to get rid of him quite easily, because he didn't want to go to court or anything. So he just went, and even though I owed him some money. So that's one way of doing it, is through the distributor manufacturer of the systems. The other way, as I think Florence has mentioned again, is if you know somebody and you know their solution is good, then go with that, because that's an important, that's a safe way of doing it. As long as you know about that system and you know about that person, then and you vet the installer yourself, that can work for you. Okay, so we're going on to design, and right, I'm just going to try and turn the chat off. Okay, right. oh, hang on, where have I got that? Yeah, design an efficient, right, design an efficient system. Avoid complexity. I did think of having a fairly complex system when I decided, no, let's keep it simple. I've got a much better chance of getting a system that works well, right? And then the other thing is, I would say, go for a monitoring system. It's essential for tuning if you want to achieve a high COP. You can get a system without a monitoring system. It'll work, but you probably pay for your monitoring system anyway over a few years. And then the third point is to have a low flow temperature, i.e. this is the temperature that your radiators or your underfloor heating gets up to. For a lot of underfloor heating systems, you can't have it above 40 degrees anyway. So looking at a system that operates between 35 and 40 degrees is good. My system, for instance, is set at 36 degrees, but because I have, if you like, almost oversized radiators, a lot of the time it's in low 30s, between 30 and 36, because it's trying to get up to its required heat output. This means that the heat pump is working efficiently when you do that. So think about those things. Anybody who tells you we've got this wonderful design, it works at sort of 60 degrees or 80 degrees and it's brilliant. If they tell you it's efficient, to be quite honest, they're lying, because the Carnot cycle, you look at the physics of it, if you're operating at 80 degrees, well, 60 degrees instead of 35, your potential efficiency is about halved. So you can't get an efficient system. The physics tells you that you can't. Okay, so then on to, so to summarize, low output air source heat pump, as low as you can possibly get. Yes, you might not be able to do a 5 kilowatt one, but I would say for most people without a large house, if your house is less than 150 square meters, you should be able to do it with a 5 kilowatt heat pump. I have a detached 1750 farmhouse, which is 115 square meters, and I'm down to now at about 4 kilowatts heat loss at 0 degrees centigrade. So it's quite possible to do it. Right, get the appropriate heat emitters. Right, sufficient radiators and or underfloor heating. I've got both. I've got 60% underfloor heating, and I uprated the radiators. What I did, in fact, was I had a lot of radiators that were single, and I made them doubles and trebles. So you got 2 panels or 3 panels. So I didn't use any more space. I just uprated the type of radiator. You can also get fan assisted radiators, which are very good because you don't actually have to have the fan on all that often. And they can work. If you're doing underfloor heating, do get 25 millimeter piping or larger. There will be a lot of plumbers who tell you, oh no, 15 millimeter works, but you will regret it when you have to pump out all the sludge from your system when it's been in for 10 or 15 years. I had problems pumping out the sludge from mine when I had the original piping was 20 millimeters for the heat pump I put in 1993. I did manage to pump it out, but if there'd been 15 millimeters, I don't know what I would have done, because I don't want to dig up the floor again. High output radiators, as I've said before. Check radiator output calcs for each room. This is quite important. Some people just do it, an installer might do it very briefly. I got very geeky about this and spent 2 or 3 days calculating it, and it has worked in terms of I've now got a very efficient system. And then the other thing is, in my house, I have buffer zones. I've got a porch where I've got the freezer and the washing machine. They don't have to be heated to a high level. So I just, a little radiator, or in my case, just a little bit of underfloor heating for those type of rooms. If you're doing extensions and so on, good idea to put in buffer zones where your outside door is, as it were. Okay, next slide. Right, cycling and sizing. This is a big issue for heat pumps. I've talked about sizing a lot, and this actually gives you, these next slides show you what happens if you have an oversized system. It'll start cycling. So to understand what cycling is, I've got two slides, one which has got a poorly set up air source heat pump, and one which has got a well set up air source heat pump. Notice the difference in COP. The poorly sourced one at a higher temperature has a COP of 1.13, right? This isn't, I didn't specially look for this, it just happened to be, I was on a Mitsubishi test site, and that was one of the properties on the site. And the other slide is from my heat pump, where it's a slightly lower temperature and a COP of 5. So let's go to the next slide. Right, to understand this slide, there's a lot of stuff on this, but what I want you to concentrate on is the bars or the spikes, and you've got orangey red ones and you've got blue ones. The orangey red ones are the heat that is coming out of the system. The blue ones are the electricity that's going in. Okay, now one thing to notice here is when this, like at 11 o'clock, when it's first turned on, you're getting a lot of electrical input to get the whole thing going without actually any output. Okay, so be aware of that. Every time your heat pump starts up, it is using electricity just to get the thing going. Okay, so although you can see there is quite a reasonable heat output after it's been going for 2 or 3 minutes, because each of these bars is about a minute apart. So what's happening is you're putting a lot of electricity in, then you're getting a bit of heat out, then it says, oh, okay, I've got up to the required heat, I'm turning off. Okay, this is when it's oversized. So it turns off after less than 10 minutes. Okay, and then it's doing the same again, starting up and closing down after a few minutes. So this, in a way, it's like if you've got a fluorescent light and you keep on flicking it on and off, you use a huge amount of electricity, because it's the same thing with a fluorescent light. It's got a condenser, it's got to get up to power, and then you're using all that electricity to get it going. So you can see there that over the period of 2 hours, it's come on about 15 different times. I haven't counted them all up. And so every time it turns on, turns off and turns on, it's just wasting electricity. So that's why you can see there in green writing at the bottom, it says average COP is 1.13. In fact, it's the green line that shows you the COP, but it's just bouncing about all over the place. Yes, you've got a COP of 6, and then it's down to nothing. At times when you're starting up, it's sort of negative because you're not getting any heat at all. So that is a system which is putting the heat pump. I don't know whether it's 5 kilowatt or 8 kilowatt. I expect it's probably an 8 kilowatt or more. It's only a 2-bedroom flat. So it might well be that the heat requirement for that is perhaps 3 kilowatts, I don't know, or less, 2 kilowatts. And clearly it's not properly set up. There's something very wrong with that system. It's so wrong, I can't tell you exactly what the problems are. But we'll go on to the next slide now, and we'll see a system that's much better set up. Notice here that the heat pump turns on at 1 o'clock and it stays on for the whole 2 hours, right? And again, notice the blue bars at the bottom. So it is actually giving out about 1 kilowatt. This is my idea of the 1 kilowatt house, that to start off with, it's slightly more than 1 kilowatt. On the right hand side, you've got it's measuring in kilowatts, and then it goes down to 1 kilowatt. And if you see what's happening there, the heat output to start off with is high, and then it gradually goes down. Okay, now modern heat pumps do this. They have a sort of attenuated compressors, and they can work at a lower output. And this actually stops them cycling so much, because if they can work at a lower output rather than turning off, that's generally a bit more efficient. Okay, so what's happening here is it's stepping down the output of the heat pump. It starts off with a heat pump of nearly an output of nearly 6 kilowatts, which is unsustainable. Well, it's a 5 kilowatt heat pump, so you can't expect that to be the case. But when it's operating at 5 kilowatts and 4.5 kilowatts or 4 kilowatts, it's still quite efficient. If you follow the green line, that shows you the COP. And if you notice that to start off with, the green line, it's up to a COP of near 6. And then after about half an hour or an hour, it's gone down to about 5. Well, that's acceptable, that's fine. Notice that when the output towards the end of the 2-hour period goes down to less than 4 kilowatts, there is a distinct decrease in the performance coefficient of proficiency for this heat pump. And I can tell you actually from other slides that when you get down to about 3 kilowatts, the heat pump is only about 60% efficient. So you have got a big, if you like, a potential loss of efficiency there. Incidentally, this slide was from 2014. 2015, based on slides like this, I put in the new set of radiators to try and get it to perform at an output of 5 kilowatts or at least above 4 kilowatts, and give me that extra efficiency, which it did. I think it's raised my COP from 3.6 to about 4 point something, I don't know what, partly because after 2016 I no longer got the feedback from the Mitsubishi trial. But I can talk to you about that, but let's not get into that now. I've got 1 or 2 more slides to do, so I need to go through them quickly. Next slide, please. This one for the Pontefract system, the reason I put it in is because in the winter it actually performs better in January, because it's, if you like, it has to try harder, so the system works more efficiently when the temperatures are lower. It doesn't perform well in October, November, whatever, where it's a COP of 1.5.
Have we lost Andy?
Andy, come in. Control to Andy. His internet's really not doing well with the stormy weather. He did debrief us this could happen, so apologies for everybody on the call. It looks like we have lost him again. He did come back in with internet. He was on the phone before. That's a shame. We're nearly through his presentation, so I'm not sure. Can we have a vote on what to do, because we are close to
Polly, are you able
7:30.
to make Ken a panelist so he can answer some of the installer questions?
That's a good idea. We can indeed. So yeah, what a shame. The Wi-Fi for Andy dropped out again. I'm just going to find Ken in this list. There we go. So Ken, oops, I'm not going to rename you. I'm going to make you a panelist. So Ken, if you're happy to take on, oh, my new laptop is not playing ball. Panelist, Liberties, you're okay to do that, and then we'll see if Andy can rejoin us. Hopefully he can get back in. He's also got the phone option. See, we can hear you.
Very, very faintly. Hi, Ken.
Hi, Ken. Good evening. Hi. Thanks for stepping into the breach. It's very, very chivalrous of you. So perhaps we could just pause it here and we could add on the last few slides to the next session. That might be the best fix for now.
Yeah.
So unfortunately, Andy's dropped out due to his Wi-Fi. He is very rural, so we have to forgive him for that. And yeah, should we just work through the questions now, seeing as we've only got very little time for them? So
yeah.
Great.
So Ken, thanks for dealing with some of the queries. So I guess some people are experiencing quotes for heat pumps that are bigger than what they actually need. Do you know why that's
a lot of the calculation software is already oversized. The EPCs generally are also oversized on kilowatts required, and we know that sometimes actually if you have a bad EPC, it can actually be beneficial to your RHI payments. So we, if the project that we get involved with is a little bit sort of touch and go on the numbers, we will run it through two separate individual calculators. And what Andy's said is absolutely correct. You know, you're better to be slightly under than over, because what he was referring to is what I called a sweet spot. Now, a heat pump, different manufacturers will, their units will have a certain sweet spot of optimum performance and optimum operation temperatures, i.e. flow temperature against ambient conditions and that sort of thing. I think I answered a question that, you know, if you took both ends of the country, you couldn't necessarily get the same performance if you put a particular unit, one in Scotland on a high hill, and then put that unit on a property, the same property, but down in the south of England, it would perform differently. And that's because of the average winter temperatures. So we tend to slightly undersized. If you are getting a couple of quotes and they're like 1 or 2 kilowatts between them, then yeah, you could most probably ask why the difference. If you have 2 quotes and one is a size 8 and another company wants to fit a size 14, that would ring alarm bells to me. So I currently have a size 8 unit and a 3-bed 1950s semi-detached, and it's an old Dakin unit. It's about 5 years old already, and at the worst winter conditions, it'll most probably run at about 5 or 6 kilowatts. And based on my calculations and heat losses of this property, I am about 5 or 6 kilowatts in the worst winter conditions.
Yeah, great. And then somebody asked, Andy suggests, I know Andy has views on this, but Andy suggested using 2 air source heat pumps, so having them at
Like
sort of
paired.
optimized for
Yes,
most.
cascaded.
Yeah.
Yes, you can if your heat load is quite excessive. Let's say it's over 16 kilowatts, so you need to maybe, let's put a figure on it. It's 22 kilowatts, so you might need two size 12s. Now, some particular manufacturers, you can actually link those two units together, and they work as one unit, and they share the load and they share the running hours.
Yeah.
One unit will be hot water and heating, and the other unit will be heating. Sometimes we've done two different size units. So we've done like, obviously for a larger property, the downstairs ground floor tends to be the bigger load. So we would fit, for example, size 12 or 14. And then the upstairs would be a smaller load because it's already gaining heat from downstairs. So we would then fit a size 8 or something like that. So we've done it both ways. One of the points I would suggest is when you design your heating system is you have a open circuit. I think Andy was touching on it. You have like an open circuit that meets your minimum output of your heat pump.
Yeah.
And that would also help with cycling issues as well. Because that's what we don't want in any heat pump, whether it be a ground source or an air source. We don't want any cycling.
Sure.
Simplicity of controls is brilliant. I'm a big fan of that. I moved away from a gas boiler in my own property. My gas boiler I installed 10 years ago as a low temperature system, and I had one indoor sensor and an outdoor sensor and a time clock, and that was all I had on my heating system. So, yeah, sorry.
No, it's fine. Carry on.
Yeah, I mean, there's loads I could talk to you about. Yeah, simplicity of controls. If you are working, say you're building a new house and you're working with a developer and an underfloor heating system, you must alliterate to the underfloor company that are doing the design that you are having a heat pump and you want to try and get the flow temperature to heat your property as low as possibly can be, because that will be near the sweet spot of the heat pump. So from a retro point of view, it's very difficult. If you have an existing system, then we would take a look at that system. We would measure all your radiators and everything else. And some may need changing, but we always try and get the flow temperature down as low as we possibly can before the radiators are elephant sized, if you know what I mean. So there is a line in the sand where it becomes almost ridiculous to fit.
Yeah, there's always a pragmatic
yes.
solution compared to
So that's, and obviously deal with the client. I mean, with the RHI MCS process, we have to guarantee that we can cover your worst case heating load with the heat pump. But, you know, some people might say, well, actually, I only like the house at 18 degrees all year round. So that might be the house that we might not upgrade all the radiators and just say, let's see how you go. Go through a winter. We recommend that you upgrade, you know, the lounge, the dining room and the larger rooms. But in the same breath, you can have the customer that wants the house at 23 degrees all the time. So it is very difficult. We have to design to a criteria, and there are specifications and regulations that we have to design to, but that has to be managed at the first port of call. The expectations have to be managed very clearly at the beginning. When an installer is coming to see you as a client, it's a slow burning technology. It's a heat pump is a big saucepan on a very small flame on a cooker,
Yeah.
compared to a gas boiler, which is a small saucepan on a very large flame. So we try and recommend that you gradually load the house is your buffer, is your thermal mass. You load the heat into it initially, and that takes a bit of energy. But once you've got that energy into your thermal mass, then you slowly trickle heat into it, and that's when you start getting good COPs. And it's actually better for your property and you as a human being to have gradual increments in heat and cooling, rather than spikes of heat and cooling, which is what we've been used to for the last 30 years of coming home, the house is freezing cold, I'm going to stick my boiler on, and 20 minutes later the house is roasting. So that's my view on it.
Yeah. Christopher has asked, he often sees your installations on Twitter. Some seem to have a lot of gubbins indoors. How do I know which I need? Thermal store, header tanks, etc. Just putting you on the spot there, Ken.
That's fine.
How do I know if the installer is trying to sell me stuff I don't really need?
Some of the I have to be careful what I say, because I don't always agree with some of the manufacturers. And even though I actually did used to work for one for a few years, so I like simplicity. But some installations are, the ones certainly I've been posting recently, are quite large installations. We are talking multiple zones, 3 floors, 500 litres of hot water. So to go with those size systems, there is added complications and control strategies that need to be put into place to make that as efficient as possible.
Of course.
For your average home, you don't need that much in the way of controls and extra devices. You may be talking of things like buffers. Now, buffers is a volume of water that the heat pump will require when it goes into a defrost. But if you had that in a big open circuit, and I think Andy mentioned that earlier, he had buffer parts of his heating system.
Yeah.
If you knew all of your downstairs radiator circuit was going to be completely open and will never switch off, you were never going to switch valves off in that circuit, then technically that would cancel out having a buffer.
That would be your buffer, yeah. And then some units, I guess, are split units, and sometimes you can get the buffer tank inside the actual internal unit. I think the Dakin Altherma is a bit like that. Yeah, but I guess it does depend on your particular project and the size of your project, etc., and how you want to manage your domestic hot water. So,
it is, yes. I mean, going back to my own system, I have a Dakin, and it's a monoblock, and I have the Octopus Agile tariff, and I have a 200 litre buffer, but I have the room for a 200 litre buffer.
Yes.
So
exactly. Yeah.
I can actually load that buffer up at night time when the Octopus tariff is cheap, but it doesn't mean my heating's on. It just means that my buffer is being loaded like a battery. I'm charging my battery.
Yeah.
Ready for my house, and that's unfortunate that I can do that. Obviously, what I do for a living, and I have the space. But you can play around with those agile tariffs with even small systems. You can load things up at night. I think your other chap was talking about doing that. Or Tristan, wasn't it?
Yeah, he was. This is really helpful information, and as we're recording the session, we might go into more depth in the next session on this as well. If you're happy to feedback again in the facilitation part.
Yeah, sure.
Is that okay, Ken? Because it's absolutely gold dust, isn't it, Florence? It's really helpful, and it's so great to have your input, as well as, obviously we've lost Andy for now, but it's very complimentary movable feast of support on the webinar, so thank you. I'm really mindful of time. I didn't want to interrupt, but it's
yeah, there's just one last question from
yeah, should we take
Anne.
one more?
She said, Andy spoke about an integrated system. Can this include PV panels, solar thermal, hot water, etc.? I can't get my head around this. Yes, I think, well, you can use the term integrated system for all sorts of things, but I think in this particular case, you can have, for example, a thermal store or a domestic hot water cylinder that has several levels of heat input into that, and it could be dumping some PV electricity, it could be solar thermally charged, and then topped up with your main heating system. So that's, I think, what Andy was talking about, but I'm not entirely sure because I was concentrated on the questions.
A lot of the newer heat pumps now have PV integration built into them.
Yeah.
You can buy third-party devices that work with older systems. I do have one of those. The Mixergy cylinder is looking quite good. I haven't actually fitted one yet, but if you don't know, it's a has I forget the terminology, but it basically heats from the top down.
It stratifies.
Yes, yes. So if you only needed to have a quick shower or quick wash in the morning, you could like effectively heat the top 10-15% of the tank.
Yeah.
And then if you had PV, it has its own built-in PV diverter. It can be linked to heat pumps as well. And then if you needed a full load cylinder by the end of the day, whatever the PV hasn't done, you could then load it up with a heat pump.
Brilliant.
So there's those sort of things available now as well. But it all depends on your lifestyle and just the way you use water and heating is a big influence on how you design and commission a system.
So it's quite nuanced, really, isn't it? It can be tailored.
Yes, exactly. Some people want to be as green and save as much energy as they possibly can, and they only want the house at 18 degrees. And then you want the next door neighbour in the same house has 4 baths a day. They want the house at 23 degrees.
Yeah. And
they're wondering why they're paying more electricity than their countering neighbour is.
Mm-hmm.
So it is very difficult, and that's why I say expectations need to be managed. But the key points are insulation. Get your insulation levels down. Try and if you do have that situation where you are a difference between a size 8 and a size 12 requirement of a heat pump, you might be able to get that size 8 by putting a few extra layers of insulation in a loft, draft proofing your windows. You'd be surprised at what difference those tiny little things make. And then you come down a level. That's quite a chunk of money between the size 8 and the size 12 heat pump.
Yeah.
Polly, Andy's in the meeting and he's asking to be unmuted.
Oh, sorry, Andy. Okay, let's get you up. It's like musical chairs today.
You're doing well, thank you.
No, thank you, both of you. I'm just trying to find you, Andy. Maybe you're hidden. Have you got your hand up?
Wrap up anyway.
Oh, sorry, you have got your hand up. There you go. Talking is permitted. You can unmute yourself, I hope.
How's that? Can you hear me?
Yeah.
We can hear you, Andy. Fantastic.
Okay. Yeah. Where would you like to go from here? Shall I can finish off the slides. One of the things about the last conversation was I was told I needed an 11 kilowatt output heat pump, and when I said no, I didn't want that, they implored me to have an 8 kilowatt one. And they said, well, you're crazy to have a 5 kilowatt one, which is what I insisted on. And actually, for me, it's the best heat pump decision I made was to go for the 5 kilowatt, even though being a detached house on a pretty windswept Pennine, sort of hillside, 250 meters up.
Wow.
You could expect a fair bit of loss, but the key thing is, know how to run your heat pump and get the right insulation in as well, and stop the drafts. I had quite a few drafts. I've not done serious, mechanical ventilation or anything like that. But obviously it depends. Every house is different, and it's a matter of getting the right one for the right house, whether it's 11, 12, 8 or 5. You've got to get the one that works, and that's an important thing to get right.
Yeah, that's came out in the conversation. We don't know how much you heard because you got kicked out or your internet dropped out, I guess.
Yeah, it dropped out, the internet went, yeah.
But we were thinking, if you're okay with it, Andy, just because we're running over,
sure.
we could add in the final slides if you're available for the session next Wednesday at the same time. Perhaps we could do a little kind of tack them on to the conversation about retrofit, because some of them fit in.
Session 4?
Session 4, yeah. It should be doable based on the content we have planned, shouldn't it, Florence? I think.
Okay. All right.
Yeah.
I'll do that.
If that's okay with you. And obviously we'll...
Or we could tack it onto session 5, I guess.
Oh, we could touch it. Yeah, we could do that as well. It's absolutely up for
whichever
debate.
Yeah,
whichever it fits in with the best.
Yeah, because there weren't many slides left, actually. We got through a fair chunk of them.
We've only lost about 3 participants in terms of time, because obviously it's scheduled for a specific time slot. So if you would rather finish up, if there's only a few, we've still got 27 participants in total, ourselves included. We could do that. It's your call.
I'm quite happy to finish it off if people think that's sensible. If
you want to, if you've only got a few left, we may as well. And it's definitely, you've come.
What I'll do, I'll go through them quickly. If there's anything we have to come back to, I'll flag that up and say, well, I'll talk about that in another session.
That's great. And we'll capture all the questions and add them to the working document and capture them and bring them back in the next session. Perfect.
Yeah. Okay, that's great.
Go for it then, Andy.
So, I think I've described how this one works well in the winter, the Pontefract system, because it's oversized. And
go back.
Then the next one after that should be, no, there's one before that. What's happening? That one. Right, one. Okay.
That's before.
I was talking about this and about saying how you've got to try and get your heat pump working at an efficient space. So like for the 5 kilowatt heat pump, I'm trying to get it working at 4 kilowatts because I know that my efficiency is good, Of course, if I'd had an 8 kilowatt heat pump, I'd have the efficiency level there is about 6 kilowatts or whatever. And that would be much more difficult for me to achieve in my house because, I'd have to put a load of extra radiators in. And actually, people would already say I'm a bit over radiated, as it were. So, so let's go on now to the next slide. In fact, it's the next section, isn't it?
Yeah, procurement.
Installation. Okay. I thought I'd done this bit.
I think.
Okay. No,
you touched on it, but not this bit. Yeah.
No, not this bit. Sorry, it's me disorientated. Right.
Okay.
Check the quality of work, but it's a tricky thing. This is where you need the Zen bit. You're trying to get everything done right, but on the other hand, if somebody thinks you're, looking over their shoulder all the time, well, then they're going to get a bit miffed, So the best thing is take the photos after they've gone home for the day so that you've got a record of what's done. And I would check up each day, and then try and introduce stuff in your conversation and ask questions and whatever. And also talk to the installer about what he thinks, and then try and have a conversation. Written communication is, for me, it's always important. If you're doing anything like this, any installation, okay, if it's a small job, you just do it. But anything several £1000s, you want some sort of written communication. You want a record of what they're going to do, and then the important thing is the changes, because changes are fine. You know, when you're doing something, you realize there's a better way of doing it or whatever. Look after your people, beverages, snacks. You know, if they feel they're being looked after, that they'll be, and also while you're having a beverage or a snack, you can talk about what's going on in a more casual way, and that will help you find out what's happening. If you had the case I had with the first installer, if it's poor quality, you can change installers. Basically, what happened was I took photos of an installation where they put stuff in, it was leaking. They came back to repair it, and it's still leaking. I took photos, and then again, they came again. It was still leaking. I took photos, and I said to them, because in fact, it's an interesting bit of law, really. There are, in certain cases, you can say 3 strikes and you're out. And so when I pointed this out to them, that, you know, legally they didn't have a leg to stand on, actually I didn't get any more emails from them, even though they'd been pressing me for money to pay, because they thought they'd done, you know, a lot, but I could see that it wasn't good quality. So I got rid of that set of installers, and then I went back to Mitsubishi and talked to them about who I should have. Operation, right, let's get on with that. So when you've got it installed, you need to tune it. And so this is where a monitor really helps you in terms of telling what's going on. And then this thing is about cycling. You can have a look on your monitor, and it will tell you if you're cycling and you're, you know, you've got a low COP. Sometimes that's caused by the thermostat. The thermostat switches on and off. With my system, I never run it on the thermostat. I always run it on the timer, and I have a look and see what the temperature is, and add an hour to, you know, run time, or take an hour off. It's a little bit geeky, but you know, that's what I do. The other thing which I had on my first heat pump was to set it for an hour minimum delay. For if it's turned off, it won't turn on again in an hour.
We lost Andy again. Polly, have we lost Andy?
Oh, not again. It's Groundhog Day, Andy. The Wi-Fi isn't on his side today, is it? Apparently. I think 3, yeah, he's been quite lucky. He's rejoined 3 times, but I mean, we're nearly very much at the end of his session, so we can just tack on the last couple of slides, and we'll capture all of the Q&A and we'll add it to session 4 and 5. I think that's probably the best course of action, given we've run over anyway. So if everybody's happy for that, we've lost a few participants because it's getting on for 7:45. So but so many thanks goes out to everyone that's come on the call, and also been a part of this network for the whole time we've been running it, and also who's new to it. It's really great to have you here, and I think that the development of the peer learning network is a really crucial thing, especially in like the Green Grant and you know, ongoing need to decarbonise our heating systems. And massive thanks to Ken and yourself, Florence, and Andy, even though he can't hear, because yeah, all your expertise and complementary information, I think, is hopefully building a much more holistic picture of how to navigate the landscape, really, because it's quite a new system that people are working with, and it's very nuanced, as we've experienced. Yeah, it's not straightforward, is it? It's a maze, so you're helping everyone navigate that maze, and we can do it better together, I think. So yeah, many thanks to everybody. I'm going to stop the screen share. And we'll, yeah, I think we should call it a night, but I really look forward to welcoming everyone back who can make it next week at the same time, same place. We'll be hosting again on Zoom, so for everyone that can make it, I look forward to seeing you.
Brilliant.